So let's look at example 4. This is the last example for today. So this one is the Bermuda Triangle. It says consider the Bermuda Triangle with vertices at A, Miami, Florida, B is San Juan, Puerto Rico, and then C is Bermuda. So we have a Bermuda Triangle with those vertices. And then the distances, I found this on this website. This is the website. It's a good website. I found it at. You can find other distances for other cities, or I believe it's for flights. But this it's a exact or actual distance from any 2 points on the globe. So that distance from Miami to San Juan, A to B, is 1,032.4. It should say miles. So let's put that in. Miles. And this is also miles. So these are all miles. And so we have the distance from Miami to Bermuda, 1,036 miles. And from San Juan to Bermuda is 961.66 miles. So what we need to do is find the angles between each of these cities. So right now we know the distances. So those are the lengths of the sides of our triangle that we know. So we need to find the angles, and the equation to help us do that is this second one here that solves for angles. So let's come down here and make a sketch again of how to solve this problem. So let's make a geographical sketch that makes sense. So this is the point A at Miami. It's point A, and then up here we have Bermuda. This is point C actually. So point C. That's the point at Bermuda, and then we have the point at San Juan, Puerto Rico. That's point B. And then we can join B and C like that to complete our triangle. If you like to put a map there, that's up to you. But this is like the Atlantic Ocean over here, and then we have the Sargasso Sea over here, and then Caribbean Seas over here. It's good to know we make some sense of what we're doing when we have word problems. It's because that's how we know its applicability and use in real life too. Is just be aware of what we're talking about and have some sort of interest or interest in the problem itself to make some sense of it. So this is the triangles that we have. So let's put the labels in there also. I'm going to put those numbers in. Make this go away. Okay, make this bigger. So we have the distances from A to C. Let's go up. So from Miami to Bermuda is 1,036. And then from Miami to San Juan, I believe it's 1,034. And then this one is 961.66. 961.66. That's the distance from San Juan to Bermuda. 1,032.4. 1,000. It's fascinating how Bermuda is 961 miles north of San Juan, and it still has a tropical climate. So that's I believe, the northernmost location to have that climate, unless it's in the opposite side of the world in the Pacific Ocean. But I don't think it is. So anyway, let's go back to our problem. So this is the information we have. We're going to apply law of cosines here, the other one, the one highlighted, and let's do that. So A in our case, we don't know what A is, so that's what we're trying to solve. So A equals cosine inverse of A squared in this case is 961.66. So this is A squared minus B squared is 1,036. And then that's B, and then we square it, and then we have C as 1,032.4. So minus 1,032.4, and then we square this. This is all over -2 times BC, and B is 1,036. 1,036 like this, and then 1,032.4. All right, so that's what we have to solve. So we're going to grab our calculator now, and we're going to solve this. Put it in there. So grab our calculator, turn it on. For some reason it turns off on its own. Oh, there we go. Okay, so let's put the calculator over here, and so we can see everything to enter in the calculator. So let's do this chunk in the parentheses first before we take the cosine inverse off. So we have 961. I was trying to put it up here, but okay. So 961.66 squared minus 1036 squared, and this should be minus 132.4 squared. This is divided by -2, and then we multiply 1036 and multiply 32.4. I do need to check if that's what I... So let's see if that's what I put in the first. Yes, because I keep writing 1034. It's 1032.4. Close the parentheses and hit enter. It's 0.5678. 0.56768, and then we take the cosine inverse. Second, let's check the mode really quick to make sure we are in degrees. Good. So second cosine of this number, hit enter, is 55.41. So the angle at A is 55.41. Let me make sure I rounded, yes, to 2 decimals correctly. So that's the angle at A. So that's the angle formed between Miami, or actually Puerto Rico, Miami, and Bermuda. That's that angle. So now we can use law of sines now to solve for the other angles. So let's solve for angle B. We have, using law of sines, we can say sine of B over B. We said is 1036. Let's put some space there. All right. So sine of B. Let's go back. And B is 1036 equals sine of 55.41 over, let's see what A is. A is 961.66. All right. So just like before, we're going to solve this problem like we have done in using law of sines, and the other problem. Well, we didn't use this today in the first problem using law of cosines, but we're going to solve this problem now. So cross multiplying, we have that sine of B. Let's put the number first. So 961.66 times sine of B equals 1036 sine of 55.41. So divide both sides by 961.66. Oops. Make this bigger now. There we go. So divide both sides by 961.66. And then we can come down here. So that goes away, and so we are left with sine of B equals 1036 times sine 55.41 all over 961.66. All right, so that means B equals inverse sine of this number here. Sine. So it's the inverse sine of this number. So B, let's get an approximation and see what B is. Let's see what. All right, let me grab my calculator again. So we have, open parentheses, 1036 times sine of 55.41 divided by 961.66. Hit enter. Oops. Might have too many parentheses. Let me check. Delete this one. All right, so the inverse sine is 0.8868. So take the inverse of this number. We get 62.48. B is 62.48. 2.48. And then lastly, to solve for c, we use the fact that c equals 180 minus 55.41 plus 62.48. This equals 180 minus, let's see what this number is. With our calculator. So 55.41 plus 62.48. And then 180 minus this number. Hit enter. 62.11. So this number was 117.89. So C equals 62.11. So those are all of our angles in our shape, in our triangle. So let's go ahead and put those angles in, and then we are done. So we have the angle A is 55.41. So let's make this thin. So we have 55.41, and then angle B is angle A. Angle B we said is 62.11, was it, or 62.48, and C is 62.11. So C is 62.11. And then 62.48. So those are all of our angles of the Bermuda Triangle that is formed between Miami, San Juan, Puerto Rico, and Bermuda. So that's it for applications on law of cosines. We looked at, in the first problem, we looked at emergency medicine, and we needed to use the equation, the generic equation that would, when we have an angle sandwiched between two sides, we need to solve for the third side. And then in the second problem, we looked at the Bermuda triangles where we knew all the sides and we need to solve the angles. And in this case, we used the second equation that solves for the angle first. And then we use law of sines and the sum of the triangles being 180 degrees to solve the problem. So that's it for law of cosines and its applications. In the next video, we'll look at a Python program that will solve problems similar to these and the first section of this on law of cosines. All right, thanks for watching. I'll see you in the next video.